In this video, we're going to look at how to make a half-wave rectifier circuit. Again, it's quite a simple circuit, but we'll be using some more features than we used in the simple LED circuit. Half-wave rectifiers provide a function of only allowing part of an AC current to pass through, in this case, only the positive part. In of themselves, they're not of much use in electronics, but we can use a slightly more complicated version of this. I'm going to do that later in the course to make a circuit which goes some way towards converting AC into DC current. But here we're looking at something quite simple, where we learn how to use a few more components and tools within MultiSim. The components we're going to need this time are a source again, and this time we'll be selecting an AC voltage, which I'll place here on the screen. We're going to be using a diode. That's what's going to perform the half-wave rectification, as it will only allow current to flow in one direction through it. And we're going to use a resistor as well, which we'll place over here. Once again, we'll have a ground connection, this circuit here. There will be some more components we're going to add in, but we've got a few bits and pieces to attend to first of all. You'll notice that the resistor has come out pointing across the screen rather than up and down, which we might like if we're going to join these components into a circuit. That's very easily remedied. If we select the resistor by clicking on it, there's a rotation icon in the bottom left option, which I can click and hold. Then I can move my mouse around the screen until it rotates the resistor to the required orientation. I can now connect up all my components, as we did in the previous video, by clicking the diamonds at either end of each component and using the wire spool to join them up. So we'll connect our power source to our diode to our resistor, and our resistor background to our power supply again. We'll connect our ground source to our current here, and our circuit is complete in terms of wiring and components. We're going to do two additional things with this circuit before we start the simulation. One, we're going to adjust some of the parameters for the power supply. So I'm going to click on the AC supply, and I'm going to go into the settings, and we're going to change our voltage to 12 volts. And we're going to change our frequency to, this time, 60 Hertz. So it's currently at 1000 Hertz. We want to change it to 60 Hertz instead. So you'll see in the box it has 1K entered. That means 1000. I'm just going to delete that and replace it with 60. And you'll see in the screen that is now showing up for our voltage supply, 12 volt, 60 Hertz supply. If I press the play button now, we're not going to see a lot happening. A regular diode doesn't light up. There's nothing really to see within our circuit. So the other thing that's going to be new in this simulation is that we're going to take advantage of this icon here, analysis and annotation. So we don't have a multimeter to connect up, but what we can do is stick these little probes into different parts of our circuits, and they'll tell us something about what's happening at each point. So unlike the multimeter, which we would connect in parallel to a component, we can take these little voltage probes and just place them wherever we want to take a reading. So we're going to take one voltage probe and place it somewhere between our power supply and the diode. So we'll put it there. And I'll take another one, and I'm going to place it after the diode, because we're interested in what happens before the current reaches diode and after the current reaches the diode. And you'll see that MultiSim's automatically made these different colors. They perform the same function, but to differentiate them, and to use the feature we're about to look at, the grapher, which shows us what's happening in our circuit, different colors are necessary. We now have everything that's required for this circuit in terms of setting it up and measuring how it performs. So I'm going to press the play icon at the top left. So you can see very rapidly on the screen the voltages are changing at both voltage probes, and it stops temporarily and moves again. It's not really giving us much indication of a clear pattern just from reading the values off. So that's why we make use of the grapher. So I click on the grapher at the top, and we can see very rapidly part of what would be an oscilloscope graph measuring the voltages before and after the diode. We want to turn this into something a little bit more meaningful though, because currently it's not something that can make much sense to us. One thing you'll notice is that we can't see the top and bottom of the waves. Now, this is an AC voltage supply of 12 volts, so we should make our minimum voltage -12. And now we can see the bottom of the wave, and we should make our maximum voltage 12. And now we can see the full wave, although it's moving very rapidly. Just above this voltage control on the right hand side of the screen, there's a time/div. That's how much time for each division of the graph we're going to see. And adjusting this to the left and right can speed up and slow down our output here. I'm going to click the button to the right a couple of times, and now we can see a lot more of our graph on the screen. So we get a sense of the pattern that's taking place here. And what we can see, if we'll pause our simulations and get a good look at this just now, pressing the pause button at the top left, is we have a full wave that's green. That's the voltage being measured prior to the diode. And then we've got this blue wave, which has a positive voltage in the normal shape, and then the graph flattens to 0 volts when we would have negative voltage otherwise. And this represents that the negative part of the wave isn't being allowed to pass through the diode. So this is what we should be achieving with this circuit, that only part of our waveform actually progresses through to where our second voltage probe is on the right hand side of the diode. If we press the split button here, we can actually bring up our schematic diagram and the grapher on the same screen. If we press the play button again here, we can see the values changing and the voltage probes as the grapher displays the readout of what's happening. I'll pause it again here. To complete this task, you have to build the circuit in the way it's been described, with the changes to the settings for the power supply to 12 volts and 60 hertz. You have to apply the voltage measurements to the circuit and obtain a suitable grapher display so that we can see the full wave at a sensible number of intervals. Your submission for this will be a screenshot, again in the Dropbox for the half-wave rectifier task. In your own MultiSim account, you might want to give this a sensible name as well, such as half-wave rectifier, which is what I'll call it here. Once you've done that, please submit it in the Dropbox, and that will be our preparation complete for the final task, which will be your assessed work in this part of the course.